Hello, this is section 1.1 in probability and statistics. This is the definition for statistics. It is the collection of methods for planning experiments and obtaining the data, and then organizing the data, and summarizing the data, presenting the data, analyzing the data, interpreting and drawing conclusions based on the data. So the green is what we're going to focus on mostly in this class. So there are, you take data from a population, or you take data from a sample. And the population is the complete set of all elements to be studied, and a sample is a subset of that population. For example, if I would, this entire class would be a population, and a sample would be if I just surveyed or interviewed or obtained data from the females, or just the males, or maybe those with green eyes, or those with brown hair. But a sample is just a subset of that population. Data is the observations or measurements taken on either a population or a sample. And then a census is a list of the individuals in a population along with the certain characteristics. And what is data? Population, sample. From population, we call the data the parameter, numeric data about a population. So notice that the P's, population, parameter, they both start with P's. That's helpful for us to remember which one goes with which. The symbols that we use are N, capital N, for the sample size, or sorry, not sample, for the population size. The mean is designated by that symbol, which is mu, and the standard deviation is given by that symbol, which I can never remember the name of. And the proportion is labeled with a P. For a sample, we call it a statistic, and it's the numeric data about a sample. And we say size, and we use a little n for that. We use an x bar for the mean. We use a little s for the standard deviation. And the proportion looks like P, and we call it hat. It's got the little hat symbol above it. It didn't show up in the PowerPoint. We have two types of data. You have quantitative data and you have qualitative data. Quantitative is like the counts and the measurements, and qualitative is more categorical and with attributes. And then we also, it's over here, sorry. We also talk about whether the data is discrete or continuous. Discrete data is measured in countable measures, where infinite data, continuous data is infinite range or data values without gaps. For example, discrete would be like counting the number of people in the classroom each class visit. So Tuesday we had 12 people, Thursday we had 15 people. Whereas continuous would be like measuring the length of your hair over a 6-month period. We could get data at any point that we wanted because there's time or days at any point we wanted. And I'll go over all of this again, not again, but examples of this stuff in class when we during class. The levels of measurement are nominal, ordinal, interval, and ratio. Nominal is the weakest and ratio is the strongest. And again, you can read here, the nominal has no order, only categories. Ordinal has order but no meaningful numeric difference. Interval is meaningful numeric difference but not zero. And ratio is, it has a starting point, it has a real zero. And again, we're going to go over those in class, and I'm going to give you some examples of them. And if you notice on your sheet that there are 10 examples there, and we're going to do those together in class. Let's talk about observation versus experiments. Observational studies are passive. They're data collection to determine association of variables. Subjects are observed and results recorded. It's kind of if you were sitting on a park bench and you were watching a Coke machine and a Pepsi machine. You're just sitting watching who puts money in what. You could say, you could be observing all the females, you could be observing everyone, you could be observing kids, and just sitting and collecting data, not talking to them, not making any interjection into their decision. Whereas a designed experiments are active methods to determine association between variables. So for this, you might set up a table in which you had cup 1 and cup 2, and you asked people which they preferred. And you have, there's something that's called confounding variables, and which have lurking variables. Confounding variables are variables in a study or experiment whose effects cannot be separated. Lurking variables are variables not accounted for in a study or experiment, but affects the results. So I want to read you this example. It says researchers wanted to determine the long-term benefits of the influenza vaccine on seniors aged 65 and older. The researchers looked at records over 36,000 seniors for 10 years. The seniors were divided into two groups. Group 1 were seniors who chose to get a flu vaccine, and Group 2 were seniors who chose not to get a flu vaccine. After observing the seniors for 10 years, it was determined that the seniors who get flu shots are 27% less likely to be hospitalized for pneumonia or influenza, and 48% less likely to die from pneumonia or influenza. So we think, wow, this is a great study, that all seniors should go out and get the flu shot. But not necessarily. The authors were concerned about confounding. They were concerned that lower hospitalization and death rates may have been due to something other than the flu shot. Could it be that seniors who get flu shots are more health conscious and are able to get to the clinic more easily? Does race, income, or gender play a role in whether one might contract influenza or possibly die from it? So confounding is potentially a major problem with observational studies. Often the cause of confounding is a lurking variable. So in the influenza study, possible lurking variables might be age or health or mobility of the senior. How can we manage the effect of lurking variables? One possibility is to look at the individuals in the study to determine if they differ in any significant way. For example, it turns out in the influenza study that the seniors who elected to get a flu shot were actually less healthy than those who did not. The researchers also accounted for race and income. The authors identified another potential lurking variable, functional status, meaning the ability of the seniors to conduct day-to-day activities on their own. The authors were able to adjust their results for this variable as well. Even after accounting for all the potential lurking variables in the study, the authors were still careful to conclude that getting an influenza shot is associated with a lower risk of being hospitalized or dying from influenza. The authors, instead of saying the influenza shot caused a lower risk of death, because the study was observational, you have to be really careful in how you word it. Now, there are some concerns in sampling. And again, there were a couple examples on the sheet, and we will go over those in class as well. But section 1.4 talks about the methods of sampling and some concerns. And the biggie is the sample must represent the population. Other concerns are sample size must be large enough to use appropriate methods, and collection must be random. Okay, so I don't remember where I stopped. I kind of got sidetracked there for a second. So sampling concerns. One of the biggies is the sample must represent the population. And other concerns are the sample size must be large enough to use appropriate methods, and collection must contain elements of randomness. And you have different types of methods of sampling. One of them is simple random sample. Hit the wrong button. You have different types of sampling techniques. You have the simple random, which each individual has an equal chance of selection. And you have the systematic, simple random is broken into either cluster or stratified. And within cluster and within stratified, you use simple random. But cluster is, you have entire groups, and from the entire group, you are randomly selected. And then from stratified, you had individuals that are randomly selected from the strata. So cluster, you have huge groups. And then strata, you have a big group that is put into different strata. And then from each strata, you are randomly selected. Then there's systematic, which is like from every nth individual, or like every fifth customer you're going to give a survey to. And then convenience is using data that's readily available. An example of convenience would be calling into a talk show. If they ask a question and you called in and gave your answer, that would be convenience.